Okay, good afternoon, pilot teachers, and good afternoon, students. Thank you, sit down. Okay, our lesson today, we're actually going to move away now from looking at the different layers of the atmosphere, and we are going to move on to looking at the next part or section that you will find in your booklet, Introduction to Climate, and that information will be on insolation or solar radiation. So today we will look at solar radiation. By the end of the lesson, you should be able to define what insolation is, and number two, you should be able to explain the distribution of radiation or the distribution in terms of how much of the solar radiation comes through to the surface and what happens to the rest of it. So those are the two activities or objectives that I'd like us to be able to achieve by the end of the lesson. Again, the objectives, one, to define what insolation is, and number two, to look at the distribution of solar radiation. But before we go ahead to looking at the topic now on solar radiation and insolation, I'd like us to correct the exercises that you were supposed to have completed for your homework. You were given a list of definitions. The definitions have to do with the zones of the atmosphere, and you were asked to look up the definition to those different words that were given. We'll check and we'll go around the class for the correction to the activities, and the rest of you will be required to make your corrections. We'll start from perhaps the front and we'll go to the back. So, Brendan, the first word that was given was the atmosphere. You are now required to give the definition to what the atmosphere is. So we'll start from here. Your definition, loud and clear.
Atmosphere is the mixture of gases that surround the Earth.
Okay, we double check. He says it is a mixture of gases which surrounds the Earth. And I think with the definition, I will agree with him, and also I think most of you should have that information. So check, a relatively thin layer of odorless, tasteless, and colorless gases and dust that actually surrounds the Earth. And that's what we're referring to with the term atmosphere. The next word, Elsie. Definition.
Troposphere is the layer of the atmosphere which, it's the lowest layer of the atmosphere which extends from the Earth's surface to a height of about 80 kilometers.
Okay, we're looking at the troposphere. That's the next word. She says it is the first layer of the atmosphere from the Earth's surface, and it extends up to about 18 kilometers. We happy with that definition? Yes? Okay, we double check. It is the lowest of the concentric layers of the atmosphere occurring between the Earth's surface and the tropopause. So we come to the tropopause, and someone will also explain to us what that particular term is referring to. Okay, the next word given.
Stratosphere. Stratosphere is the layer of the atmosphere which lies immediately after the troposphere and extends in height from 20 to 50 kilometers.
Okay, very good. He's given the definition to what the stratosphere is. We double check. From what he has read out, it's definitely correct from the information on the monitor. One of the concentric layers of the atmosphere occurring between the tropopause and the stratopause. So it is the layer which is between the troposphere, the first layer, and also the third layer of the atmosphere, which is the ionosphere. But we are using the words tropopause and stratopause because they are boundaries that marks the separation of one zone from the next zone. The next word given, the ionosphere.
The ionosphere, I think, insulative atmosphere layer that extends from 80 kilometers at the upper portion of the mesosphere.
Okay, we're looking at the layer at the upper portion of the mesosphere, and it extends from about 80 kilometers, or 50 kilometers, we should say, 50 kilometers and beyond. Okay, we double check with the definition that is given. The layer of the atmosphere above the stratopause and beyond. The next word given, the tropopause.
tropopause, boundary separating the stratosphere from the troposphere from the stratosphere, where there is a decline in atmosphere temperature.
Okay, very good. So when we look at the tropopause now, it is simply the boundary that separates the troposphere from the stratosphere. Okay, we double check the boundary between the troposphere and the stratosphere. The troposphere is the first layer of the atmosphere. The second layer is the stratosphere. The boundary that separates that layer from the other one is referred to as the tropopause. Okay, the next word. The next word is stratopause.
It is a transitional zone next to the upper layer of the stratosphere, which is marked by a non-increase of temperatures.
Okay, very good. We double check the definition that is given is correct. From the monitor, it is simply the boundary that separates the stratosphere and the ionosphere. So the boundary that separates the stratosphere from the ionosphere plus what Celeste has given can also be put together with the definition of what the stratopause is. Remember, we had stratosphere, ionosphere, troposphere, all of those are zones. The stratopause, the tropopause are all to do with boundaries, which separates one layer from the next layer. Okay, the next word is mesopause.
Mesopause, the upper portion of the mesosphere where there are increasing temperatures.
Okay, very good. We can have that as our definition. Also note, the mesopause is supposed to be the boundary also that separates the mesosphere from the thermosphere. The mesosphere and the thermosphere are the two zones which are located within the ionosphere. The separation of one from the other is a boundary which is referred to as the mesopause. Okay, the next definition or word given, mesosphere. Catherine.
Mesosphere is the atmospheric layer which lies between the stratosphere and the thermosphere.
Okay, the layer that lies between the stratosphere and the thermosphere. Okay, good. We double check with the definition given. One of the concentric layers of the atmosphere occurring between the stratosphere and the ionosphere. Okay, I've missed out the thermosphere, but we know that within the ionosphere, we come to the mesosphere and then the thermosphere before the ionosphere or the exosphere. So within that zone, those different zones of the atmosphere, that's okay. And the definition Catherine is given is correct. We can also make reference to the information from the monitor. The exosphere, the next word, Francis.
Exosphere is the outermost layer of the Earth's atmosphere.
Okay, it's simply the outermost limit or the outermost layer of the Earth's atmosphere. Okay, we double check the exosphere, the outermost zone or layer of the Earth's atmosphere as given by Francis. Shelley, the next word you are supposed to define is the aurora. Your definition to aurora.
A natural display of light in the sky that can be seen with the naked eye only at night.
Okay, natural displays of light that can be seen with the naked eyes occurs during the night. We could be a little bit more specific because it does not occur right throughout the world. It only occurs in specific regions. And if we had to be specific, what would be those specific regions that those lights appear? Within the polar, yes, the polar regions. In the northern hemisphere, at the North Pole, it is known as the borealis aurora. And in the southern hemisphere, the South Pole, it is referred to as the australis aurora. Okay, so they are brilliant displays of lights, definitely. They have to do with the electromagnetic radiation resulting then in those lights occurring. Let's check the definition given on the monitor, and perhaps some of you might want to make note of it. We'll have to do that quickly. Aurora, according to the information from the monitor, it's popularly called the northern or the southern lights, the northern or southern lights. The luminous effect of electromagnetic phenomena in the thermosphere mainly. We should all know what the thermosphere is now. It is thought to result from magnetic storms and solar discharges during periods of high sunspot activity. And since some of you are making note of that, I'll give you at least a minute. And then there's a second slide for further explanation of the aurora. Okay, we'll continue. Looking at the last sentence given there, it says that it is thought to result from magnetic storms and solar discharges during periods of high sunspot activity when electronic particles may be projected into the Earth's magnetic field and there accelerated to high energy sufficient to cause ionization of gases. This particular light, the aurora, is actually manifested as streamers, veils, sheets, and rays of white, red, and green at heights of about 100 kilometers in the night sky. And it is mainly marked in the polar latitudes, the North Pole and the South Pole. Okay, that's to do with the aurora. The next word that you were supposed to also define, and it's also the last for our definition, Dorothy.
Ions, electrically charged particles formed by losing or gaining electrons.
Okay, very good. We're looking at ions. Ions are generally electrically charged particles which are produced when a substance is subjected to the process of electrolysis. So with the definition given on the monitor, maybe we'll go through that information again, and perhaps some of you might want to make note of it. It tells us there that ions, mainly found in the last layer of the atmosphere or the ionosphere, it is made up of electrically charged particles which are produced when a substance is actually subjected to electrolysis. Note also that in nature, ions are thought to be formed from the earth or by the action of cosmic and ultraviolet rays or radiation. Particles which have excess of electrons, they are termed positive ions or cations, and those that are having deficiency are termed negative ions or anions. Okay, so we're looking at ions and what they are. Again, note that these are formed in nature. They are generally formed through the from the earth or by the action of cosmic and ultraviolet radiation. Okay, from that information also, note that we have covered already the different layers of the atmosphere. And from the different layers of the atmosphere, we found out that ions are substances which are features or characteristic found mainly in the last or the outermost layer of the atmosphere. The reason for why that layer is also called ionosphere is simply because of the fact that ions are actually found or formed in this particular layer of the atmosphere. Okay, any queries or questions you'd like to ask with regards to what we have covered on the work on the zones of the atmosphere, layers of the atmosphere or zones of the atmosphere? Any queries? Questions? Okay, if you have no queries or questions, then we are ready now to move on to what I'd like us to cover for our lesson today. And what we're going to look at today will be basically on solar radiation and insolation. If you make reference to the booklet on climate, you will find that information on page 6 of your booklet. And with that information on page 6, it is very brief, the information provided on solar radiation. And we're going to do a lot more or some more activities so that we understand what solar radiation is and what insolation is. Look at page 6 of your booklet. under the work on insulation. I think it's page 5. Okay, page 5, sorry. Page 5 of your booklet. Under the heading on solar radiation, that is what we are looking at today. For the introduction part of our work on solar radiation, I'd like us to look at the introduction from the handout that has been distributed. And then from here, we'll go over to the booklet and the diagrams that are presented on our monitor. Source of atmospheric energy. The sun, one of the smallest stars of the universe, is the only significant source of energy for the Earth's atmosphere. From this star, whose diameter is more than 100 times the Earth's, and whose surface is estimated to have a temperature of about 10,000 degrees Fahrenheit, streams an immense and continuous flow of radiant energy. The Earth, which is nearly 93 million miles or 150 million kilometers from the sun, intercepts less than 1/2 billion part of the solar output. Yet, many of the physical and all the biological phenomena of the Earth owe their existence to the small percentage of the sun's total energy. The radiant energy received from the sun, transmitted in the form of short waves, 1/10,000 to 1/100,000 inches in length, and traveling at the rate of about 186,000 miles a second, is called solar radiation. Roughly, 1/6 of the solar radiation can be perceived as light. The other waves, some shorter and others longer, cannot be seen. Since solar radiation is the single important source of atmospheric energy, its distribution over the Earth is the ultimate cause of most weather and climatic phenomena. But solar energy is not just a control of climate. It is a major climatic element as well. And in many ways, it directly affects the growth and character of plant and animal life. So therefore, for us to be able to look at the next chapter, which is all about climate, it is also very important for us to look at where is this energy coming from to allow the different climatic and also weather phenomena to actually take place. And now we know that that energy comes from the sun as solar radiation. From the readings also, we would have noted that solar radiation comes through the surface, but then not all of that solar radiation from the sun reaches the Earth's surface. Along the way, certain portion or parts of it is actually either absorbed or reflected or scattered. And in the next part of our work, we are going to look at what happens to solar radiation and how is it actually distributed, how much of it reaches the Earth. The percentage or the amount that actually reaches the Earth's surface is referred to as insolation. We make reference now to the information from our booklet on page 5. If you look at the information on page 5, it tells you that solar radiation is simply the energy from the sun. That's the definition to what solar radiation is. It's simply energy from the sun. This energy stirs the atmosphere into motion. The primary effect of solar radiation is to actually hit the Earth and the air above it. But note, not all of the solar radiation or energy that reaches the outer atmosphere actually penetrates to ground level. Much of it is actually scattered and reflected back into space from clouds and impurities in the air. Of the energy which does not get reflected into space, some is absorbed into the atmosphere, some reaches the ground, but is reflected back into space off surfaces such as snow, whilst the remainder hits the Earth's surface. Therefore, the amount of solar radiation that reaches the ground is called insolation. So 2 words that we have used today. We look at the first one, solar radiation. Solar radiation is simply energy from the sun. That's important. You make note of it. And the second word that we have looked at is insolation. And insolation is simply the amount of solar radiation that reaches the ground. Now we look at what happens to the solar radiation, which actually comes through to the surface. Okay, if we go back to a diagram here showing the different layers of the atmosphere. We have covered this part already. From our readings, we found out that solar radiation is simply radiation or energy that reaches the surface. Solar radiation can come through the form of waves. There are many different waves coming through in the form of that solar radiation. But note that not all of those waves reaches the surface. The amount that reaches the surface, we will find out very shortly when we look at the budget in terms of what happens to all that radiation from the sun. Some of the waves that comes through are waves such as the gamma rays. We also have the X-rays, the ultraviolet rays. The radio waves, they come in together with that radiation or waves from the sun. Then we also have the infrared radiation. Out of it, we also have the visible light, which is part of the radiation that comes from the sun through to the surface. The visible lights are what we are able to actually see. All the others are also waves or radiation, but we cannot see them. They are invisible. The only visible radiation is the light, which comes from the sun, which makes it possible for us or for our eyes to actually see. So if you look at this diagram generally shows those different rays together with the radiation from the solar energy. All the other rays are invisible, except for the light rays, which are visible. The other rays, they can actually be detected by special instruments, like say, for example, the radio waves that comes through. We use those then for communication. The infrared radiation, perhaps those people who take shots in terms of photographs and all that, this is also present so that it makes it possible for photography or photographs to be taken. During the time of war, perhaps in developed countries today, the binoculars that the soldiers wear so that they are able to see beyond and also see in places when it is very dark. Infrared radiation makes it possible for them to detect the heat so that they can see maybe what's beyond the building or what is inside the building. So those different rays which comes from the solar radiation, we do not see them. They're invisible, but they can be used for different purposes. The visible rays is what we are able to see. Okay, we move on. Note that we mentioned when we were looking at the ozone layer of the atmosphere, which is found in the stratosphere, we also mentioned that when solar radiation or energy from the sun comes through, not all of it comes through the surface. Some of it gets to be reflected back, others get to be absorbed. On the monitor, we have a simple diagram to show us about the solar radiation budget. You will also find this particular diagram in your workbook on page 5 or in the booklet on page 5. You can make reference to the booklet or you can make reference to what is shown here. If the 100% of all of that solar radiation comes through to the surface, then it will become very dangerous for living cells. The 100% does not come true. Along the way, 15% of the solar radiation gets to be absorbed by the atmosphere. Okay, 15% is absorbed. So the ozone layer is one of those layers that also helps in the absorbing of that 15%. The poisonous ultraviolet radiation coming through can get absorbed in the atmosphere the ozone layer serves as an example. 6% of all of the solar radiation is actually reflected back into space by the atmosphere itself. Absorbing means to soak it in. Reflecting means it bounces and then it gets transmitted back. So 6% is reflected by the atmosphere. So if we look at this diagram, the black line here showing perhaps the atmosphere, the brown area here showing the Earth's surface. In between here, we have the different layers of the atmosphere. So 6% of the solar radiation comes through and then it is reflected back into space by the atmosphere. About 27% of the solar radiation comes through from into the atmosphere through to where the clouds are, and it is reflected back to space by the clouds. So the clouds, very important, they also serve as an insulation or an agent which reflects some of the solar radiation back into space. Here, we are looking at approximately 27%. Then we have about 2% of all the solar radiation that comes through is reflected back into space by the Earth itself. So on the Earth, we have things like snow. Snow and ice might be some of those features that reflect 2% of the solar radiation back. So if we had to add 15 plus 6 plus 27 plus 2%, what will that give us a total of in terms of percentage? 50%? Yes? So that's 50%. So what happens to the other 50%? It is now absorbed by the Earth. So the Earth absorbs approximately about 50% of all the solar radiation. Upon the Earth absorbing that, what happens now is the Earth uses what is or has been absorbed as heat for the Earth's surface, and also this then contributes mainly to the variation and the different climatic types that we have also. So generally, the diagram here shows us the budget, what happens to that 100% of solar radiation that comes through. Not all of it reaches the surface, only about 50%, because along the way, the other 50% gets to be absorbed or reflected. Any questions with regard to that information? No questions? Okay, if there are no questions, then we're going to do two lots of activities. I would like you, first of all, to make note of an exercise that I'd like you to use so that you can complete the diagram. And the diagram is going to be a similar diagram, but perhaps not drawn in this manner, but it is drawn to show the same information on what happens to the amount of solar radiation when it is actually penetrating through the atmosphere and coming to the surface. Okay, first of all, what I'd like you to do is using, the instruction which is given here, I'd like you to make note of the following information. So you are going to copy that information into your exercise book. After you copy that information, you are going to make note of a diagram of which I will also put up on the monitor. The diagram will contain blank spaces of which, from the information that you will copy, you will put the units into the blank space so that it shows you what happens to the amount of solar radiation which penetrates our atmosphere and comes to the surface. Okay, you make note now of the following information. 27 units are reflected back to space by clouds. 6 units are scattered in the sky, giving it its blue color. 2 units are reflected back to space from the Earth's surface. 50 units heat up the Earth's surface, and 15 units absorbed by the atmosphere. I'll give you 2 minutes to make note of that, and then we have a diagram to also copy. Okay, have we made note of the following information? Yeah, okay, we're ready now to copy the diagram. When you copy the diagram down, I do not want you to start on those activities as I'm going to give you that work to complete for your homework. So just make note of the diagram, and then from the diagram, you will be required to fit the units, the numbers especially, correctly into those boxes which are given. So all you're doing is you make note of the diagram, and then for your homework, you are going to put in appropriately the units that comes into those different boxes. I'll give you 5 minutes for your diagram. You can fill in while you're waiting. You simply put down the number of units per information given. Have you made note of the diagram? Okay, so your homework is simply from the information you copied down on the different units of solar radiation and what happens to them. You simply write down those units into the spaces provided. You had five lots of information on the different maybe divisions of units to do with solar radiation. And if we assume that there's 100 units of solar radiation coming through, what then happens to each one of them? And you are given a clue to help you put in those numbers. And that's what I'd like you to do for your homework. Okay, looking at what we have covered in our lesson today, Kathy, can you define what solar radiation is?
Solar radiation is simply the energy from the sun.
Okay, very good. What we've looked at today, solar radiation is simply energy from the sun. Silo defined what insolation is.
The amount of solar radiation that reaches the ground.
Okay, so we look at all the energy from the sun. The amount that reaches the ground is referred to as insolation. That then will also bring us to the end of our lesson. Class, you will be required to complete those activities for your homework, and we will go through the correction in our next lesson. If you can stand up now, please. Okay, to the pilot teachers, our keyword for lesson 93 is insolation. Good afternoon and thank you, students.